wasn't sure about this at the start, but then a friend of mine said something that just made all kinds of sense. She said, think of it more as a conversation. I like that.
I like that. Do you like that? I like that. Let's have a conversation, everybody. Oh. Okay, you can hear me. Alrighty, alrighty. Pause this here, and we'll get going. Make our little announcement. That's probably a good first step as well. Bring that up for you guys. I already wrote it again because I forget all the time, and I write them incorrect. It's a better system now. It's a better system now. I promise. Nix Craig, let's go! Thank you so much, Nix Craig. I appreciate it. I appreciate it. Let's do this. Let's go. I asked earlier today on the Discord if I was going to stream very soon, what should I do? And the outcome was we're going to do assembly. So welcome to the stream, everybody. Welcome, welcome. We're officially live. Terrific Tables at 55 says, hello. How's it going, Terrific? Thank you so much for tuning in. Nix Craig was here before I even went live. So shout out Nix Craig. Nix says, I've switched to NixOS on my desktops. I have truly devolved. Oh no. Should I know what NixOS is? Is that yours? Nix Craig, NixOS? Okay, I should probably get started here. No, it's like Geeks, but not bad. Oh, nice. It's like Unix OS, but newer. Okay. Okay, okay. Well, let's start programming. We are on the stream, and it is now 2023. How about that? How about that? Isn't that crazy? Isn't that crazy, chat? Okay, it's now 2023, and we're going to be doing some x86-64 assembly. Basically an intro. We're just going to, let's call it a walkthrough. I don't know what I'm doing, though, so let's do it. First off, let's just do basics. And then get into, hopefully, a file. And we'll just call it main.s. We can write both Intel and GNU assembly today. Terrific Table 55 says, it's a Docker, but from command line and without containers, and it's also a package manager. Little sus. No, that sounds pretty good for an OS. All right. Who wants to do some assembly? First of all, just like when you're writing a new C program, the first thing we should probably do is try and get a main function so that we have an entry point. And to do that in assembly, really all you need to do is, I think I'm already in assembler mode, but it's fine. All you really need to do is make a label. And a label is just any characters that are a valid C identifier or a valid label, followed by a colon. So you can do main underscore blah blah blah. Well, not like that, because Emacs has fun comment insertion. But we just want main. Because main is what's called from the C runtime, and this is a little confusing, but we're going to be writing an assembly program that runs in the C runtime because it's a user space program, and that's usually how user space programs are invoked by an OS. Terrific Table 55 says, I also use it, but not mainly though. I mostly just use its package manager and other OSs. Very nice. From main, we're going to need an assembly instruction to, first off, return from main. That would probably be a good idea, so that we don't just try and start executing whatever bytes are in this file, and we actually have a return point, right? And then I think with this, what we're going to do is navigate here in a terminal. Let's try out eShell. I don't know how this is going to go. This is new waters in a new Emacs. Okay, so now we have an eShell open. And basically, what we're going to do is we're just going to use, at first, as to compile main.s. And it worked. And you see we now have a.out. What do you know? And if I do as help, then you can see a whole bunch of stuff comes up. But mainly what we're interested in, yes, I'm scrolling because I'm used to a terminal. What we're interested in is that all it really cares about is that you give it options followed by assembly files, right? That's kind of all the usage here is. So you can see that there's plenty to do. And you can even set things like all sorts of things. There's all sorts of things that we're not going to get into now, like include directives and warnings. Most of this you don't have to worry about, but some key things to take away would probably be the -O if they have it. Do they have it? They should have it. It's a little easier to read. There we go. They don't have it here. Well, there you go. I'm sure they support it. It's just not in the help. That's really funny. The basics. So when we compile as, or with as, our assembly you see on the left, it generates a file a.out. And you can see this is an Intel AMD 64 COFF object file, no relocation info, no line numbers, not stripped, 3 sections, symbol offset, blah, 9 symbols. And if we did like an object dump on a.out, you can see that basically there's main defined. There's a text, a data, and a BSS section, which is something we'll get into in a little bit. And effectively, that's all we have. There's really not much else here other than that it has debug information because that's default. And you can see it's not really an executable. This is actually an object file as file, so helpfully pointed out to us. It's a COFF object file, not a COFF executable. So what gives? With a C, you can just use GCC, and guess what? It all works. But GCC is even more complicated. It's actually a compiler driver. We're not going to worry about that. What we're going to worry about is with how do we turn an object file generated from our assembly into an executable. If anyone has any questions, by the way, I'm open to it. Nick says, any hand unrolled loops and SIMD intrinsics? We might get there. We might get there. If I can speak today, that is. So we're going to need the help of another program, LD. LD is basically, oh boy, where is it? We're going to do, there we go. It has very similar usage. You just pass it files and give it options. And a lot of the options we're not even going to have to worry about because the defaults are sensible. Ones that are probably of note are -L, which is search for library libname and attempt to link it into the executable. -L and give it a directory to search for the libraries that you are feeding to -L. Next. L plus D's nuts. Yeah. Yeah. Truly educational content. L plus D's nuts. We need to get that on a t-shirt. Okay. Here's -O, where you can set output file name. You can optimize the outputted file. Is that like link time optimization? I don't even want to worry about that. What we're going to do is just link this file that so mysteriously got generated and then check what it made. Hey, look, a.exe. And what we can do is run a.exe. Now, what is the thing for the last exit code? Does anybody remember? Oh man, isn't the last exit code like $#? I'll get there sometime. Does anyone remember the shell intrinsic to access the last exit code? I don't remember. I'm Googling it. I'm going to Google. It's $? I was so close. It's not going to work now. Okay. And we can see that we ran a.exe. Saraid says, yep, what's up, Saraid? What's up, Saraid? Thank you so much for tuning in. How's it going? We are going well. As you can see, we used as to generate an object file from this very simple assembly, right? And as then created an a.out object file for our OS. It was a cough object file, but it could be in any format, really. And then we linked that object file with LD into an executable. And then once I figured out I remembered that $? Is the way to get the last exit code of in a shell. Then we could run the executable that it generated, the linker generated, and it actually returned 0. It did nothing. So let's try and make our program do something. This is boring assembly. Let's make it a little more fun. Terrific table 55, don't you need a .ld file to tell LD what to do with the object file? No, you do not. $# is the number of arguments. I know, I couldn't remember. I was like, is it $X? It's one of these, man. They're all the same in my head. So terrific table 55, you do not need a .ld file or a linker script is what you are referring to. And we can get into that later, but basically, one place that you do need it is, for example, when writing a kernel. This is a linker script for the Lenser OS, and you can see that because we need to control exactly where the physical memory and the virtual memory of the kernel is placed, then in the memory address space, then we actually have to deal with a linker script to tell it, hey, place this at this address, place this at this address. Nowadays, LD comes with hundreds of these linker scripts that are default to do all sorts of things like convert ELF files into cough files and cough files into ELF files, and then how to make cough files into cough executables and all that stuff. Those are all built in, so you can see this output format. I basically just hook into this other linker script that is already built into LD, and then I kind of just extend it and align things as where they need to be. This is not needed in any assembly program that you are not writing a kernel. I mean, any assembly program you can just compile regularly. And one thing that I didn't talk about, remember how I said GCC is a compiler driver? It's not a compiler itself. It's a GNU compiler collection, right? So the compiler collection is actually invoking all different sorts of programs to end up with your final executable. And the cool part about that is that the compiler driver is so smart that you can actually just feed it assembly. Perfect. And you can see that it says, hey, it compiled it, and then it had trouble linking it because there's an undefined reference to win main, which is a Windows-specific thing. I think for this, the solution would be, oh god, don't do that. That's the first ever thing I think I typed in eShell. That's amazing that that's still there. I think we may need to make this a global, and that may help us. There we go. So, if you don't know, there are assembler directives in GNU assembly which start with a dot. And these are like little, they're not actual code that will be generated, but they are basically metadata about the code that you need to tell it. For example, main, this label, is a global symbol. And what this does, if we take a look at this file now, we're going to use ls, and you can see that a.exe was generated. And we're going to do -o gcc.exe. That's probably not good to name it gcc.exe, right? So what we're going to do is name it something else. That's smarter and doesn't overwrite existing programs, like made with gcc.exe. That's a better one. Remember, if you're on Linux, you don't need the .exe. And then you can see that that made an executable, and we can run that executable. Okay, there we go. Don't press tab, I guess. And then do the same thing as before. You can see it exits 40, which is fine. Zarias says, I never knew you were on a Windows machine, or more like never noticed. That's awesome. How's it going, Zarias? Thank you so much for tuning in. Izidiyush says, hi, Lens. How's it going, Izidiyush? What's up? Sarade, gcc.gcc.exe. A few minutes later, why does this program, which contains obvious errors, compile? Lamau. Izidiyush says, Happy New Year. Thank you, Izidiyush. I really appreciate that. Happy New Year to yourself. What we can see is that that does generate an executable. Cool, cool, right? And the return value is not 0, because what you'll notice, we're not returning anything from main. We're just returning, and we'll get to that. But what I was also going to get to is that with this new object_x a.out, you can now see that main is actually a global symbol. Remember how before, you may not have noticed, but these were in a different spot when it was not global. You can see that it is in a different, oh man, where is it up here? Okay, so we're in section 10020. And this is in section 10060. I think this has to do with the, I can't remember what SCL is, honestly. This is not executable, no, that's not executable. I've been doing too much OS work. Izidiyush says, what are we doing today? It's in the title. We're doing x86-64 assembly, and we're kind of just going through the basics of it. I'm answering questions as they come in. I would love any questions on assembly that you have. I'll do my best to answer them. But as you can see, this basically puts the main symbol in a different section and makes it actually a global symbol, which the linker, by the way, there's probably better ways to inspect the symbols of an object file. I know. I'll get there. But basically, the linker can now take main and go, oh, this is actually a symbol that we should provide to all of the object files that we are linking with. And if more than one of those main symbols shows up, well, then that's an error, and you get a multiple definition of blank, or redefinition of blank, right? And then if there is no definitions of main, but one of the object files requires it, then it will do the opposite, basically, and it will say, hey, there's an undefined reference to this symbol because it wasn't made available as a global symbol in any of the object files we're linking with. Anyway, let's go back a little bit to the basics, and let's try and do something in main. And what we're going to do is just move a number, and numbers in GNU assembly are prefixed with a $ syntax, constant numbers. So, yeah, we're going to do that. And we're just going to move 69, why not, right? Into a register. Now, if you don't know about registers, now's a good time to talk about that a little bit. Basically, you close for a little bit. You have a CPU, right? And the CPU, I'm sure you know this, does things like adds numbers. But how does it actually add two numbers? How does it even have a number, right? It has to somehow store each of these numbers in a place and then store the result somewhere else, or in the same place as one of these, right? And that's actually exactly how it happens. There's 16 of these registers, right? Don't mind the comment syntax for now. A CPU has 16 registers, so let's call them like R0 through ... R15, right? For now, I gotta put 3 at the beginning of these, or they keep indenting. It's a mess. What a comment syntax. Anyway, you can do object dump -t to view just the symbol table. Bless. Thank you so much, Saraid. Yanariel says, what about NASM ELF64? Those are two different things, but I will totally go through writing the same program in Intel syntax versus GNU syntax, because I'm familiar with both. Isidiush says, why only 16? Because we are on x86 64, and that's how the hardware is designed. x86 64 CPU has 16 general purpose registers. That's just how the actual physical CPU is laid out. And it's because with 16, you can do most things that you need. That's pretty much it. And there's not even really 16, there's like 14, if you really count like the base pointer and stack pointer, because those are... Isidiush says, is it a standard? No, it's hardware. It's how something is built. It is how the x86 64 architecture is built, is architected. And the standard for that can be found if you look up Intel Software Developers Manual. Let me show you guys this. This will be interesting. So you can see the Intel Software Developers Manual. You get this link from intel.com. That's the one to go to. I'm sure it'll be different depending on where you are and what language and stuff. And then it says combined volume set of blah, blah, blah. And then there's the 4 volume set. And basically, what you're going to want to get is either the combined volume set if you want everything, but you can actually get certain parts of it, which includes parts. For example, volume 2 is the full instruction set reference. Let me make this a little bit bigger for you guys. Is that better? Why only 16 is a standard? Basically, that's how it's architected, and it is sort of a standard. It's in a manual on how to use the hardware that they have developed for Intel 64 and IA32 and all sorts of that stuff. And this is a really long, complicated manual because it details exactly how the CPU works, but this manual is needed when creating an OS, for example. I have a local version of this manual that I use all the time to make sure that I'm getting things like stack frames and interrupt stack frames correct. Anyway, that's enough for now. Probably should have kept that window open. You have a bunch of registers, and these registers can store a number. That's all we're going to think about it for now. They can store a number. And one general use case, the largest number they can store is equivalent in most architectures, and definitely in x86 64, which we're talking about, is equivalent to the maximum addressable memory space. Basically, if you only had, let's say, 16 bytes of memory, right? 16 bytes of RAM, then each of your registers would be the size of, well, how many bytes of RAM can you store? You can store 16 bytes. But that's not what we need. We just need to represent the number 16 as a binary number. And if you don't know, we can take a look at basically the number 16. And it's hexadecimal 10 or octal 20. And in binary, that would be, let's think about this. The lowest one would be 1. We don't want a 1. There's a 2. We don't want a 2. There's a 4. We don't want a 4. Right? So basically, if we write a 1, then this is 1, 2, 4, 8, 16. So the binary number, 16, can be represented in 5 bits. So that would generally, if you had 16 bytes of RAM maximum, according to the CPU architecture, then you would only need 5-bit registers. But because we have lots of bytes of RAM maximum nowadays, right? Gigabytes, hundreds of gigabytes, then that means this number is actually 64 bits long on x86-64. I don't think it's necessarily tied to memory addresses because segment registers were basically introduced so you can address more memory than the max address that fit in a register at the time. You're right. On any architecture, you're correct. x86-64, it is tied to that because you can only address memory using a register and the segment registers no longer function. But you're correct, it used to work like that where the largest number they can store was not equivalent to the maximum addressable memory space. That's why at the beginning I said when writing this, on most architectures, and usually only the newest ones, because it used to not be viable as far as cost and things like that. Anyway, I'll get back to writing this really soon. We now have 64 bits in each register, and these registers all have names, which you can learn and really memorize. They'd never change. And there's a few of them, so don't get surprised if it's a little scary. There's our SP, our BP, right? 1, 2, 3, 4, 5, 6, 7, 8. And then we should have R8, R9, R10, R11, R12, R13, R14, and R15. How about that? These are our 16 general purpose registers. Is it a use says gonna screenshot the whole stream? This is insightful. Awesome, I'm so glad. So we now have 64 bits and 16 64-bit numbers that we can access. These 16 64-bit numbers are named this, and you can access them by using mnemonics. And basically these are instructions that refer to opcodes based on the amount of operands. We're not going to worry about that right now. But what we are going to worry about is that racks is kind of a special one because it has been defined in a multitude of specifications to be the return value of a function. There is no reason that this has to be done. This is just what is agreed upon by the programming community. For example, in C, when you look at a C compiler's output, the output of the return value of the function will be in racks. So when are we going to build a new roller coaster tycoon? I mean, really, you should just contribute to like OpenTTD, right? It's already a project and it's going. I'm sure there's issues you can work on. Anyways, we can use this name after a percentage sign, and you can see the syntax highlighting even helps me out here and says, hey, this is a register. It's after a percentage sign. So we would like the racks register. And in GNU assembly, by the way, terrific table, I saw your message earlier, I forgot to read it out loud. I can't link the file NASM compiles from assembly and file outputs very short file, no magic. That is true because we were not using NASM to compile this, we were using AS and LD or GCC. And if you have GCC, then you need to make sure this is a global because it does way more linking. Anyway, this program, main, we would now like to say that it moves, which means it moves this number, this literal integer number, into racks. So now racks stores the number 69. Cool, right? And all we should have to do is do what we did before, where we do a little as in main.s, ld on a.out, its file that it generated, and then we can just run a.exe and echo the last output. And what do you see there, folks? What do you see there? That's this number, isn't it? Oh, isn't that cool? Are you using the tree sitter grammar for this by any chance? Is there a tree sitter grammar for assembly? I don't know if there needs to be one. It's pretty regex nice. You know what I mean? It's pretty nice to work with regex per line on assembly. So it says, I don't know, I'd have to check. I mean, there's not one in the official list. There's an Emacs Lisp one in the official list, but that's built into Emacs now, and I use that. But yeah, assembly languages are fairly simple. But to be fair, if there isn't one, I should probably write one, because that way LITE could have syntax highlighting for assembly. Okay, to answer terrific table, it's not compiling. Zarios says copium. What? For my own text editor supporting arbitrary languages, syntax highlighting? That's not copium. That's braggium. I'm proud of that one. I'll brag about that forever, man. Okay. Also, it's so funny that me and Soding literally chose to do syntax highlighting on the same day. He just chose to stream it and make it educational because he's awesome. Anyway, to answer your question, terrific table. This doesn't compile in NASM, and nor should it, because NASM is a different compiler, right? And a whole different set of compilers, basically. And what we would like to do to convert this into Intel is one, I'm just going to rewrite it, is probably the best way to do it. I think it's .asm for NASM. I can never remember. And one thing about NASM, or Intel syntax assembly, is that numbers do not need a prefix. You can just type the constant. Registers do not need a prefix. You can just type the name. And most confusing of all, the source and destination registers, or operands as I should put it, are swapped. Whoops, that's the wrong way. That way. These are swapped. So this, in Intel, I don't think NASM cares about the file extension. I typically just .s because that's what I'm used to. .s means specifically GNU assembly, I thought. And .S means specifically user-written GNU assembly. I can't remember. First time chat from Nashiora. Oh, ah shit, I'm half an hour late. Don't worry about it, mate. We're still at the very beginning, as you can tell. If you have any questions, they're encouraged. .S is assembly that needs to be preprocessed using the C preprocessor. Oh, nice. That's what it was. I can never remember. I remember I needed that in Lenser OS. Anyway, I don't think I do anymore. This, in Intel syntax, should be the same thing as this in GNU syntax. It's a little bit bigger, though. And you can see they're very similar, but they're confusingly different. But don't worry, with time, you'll learn one. At the beginning, pick one and stick to it, and then the other one will come with time, as you need to work with it more and more. To compile this NASM, all we have to do, is use NASM on main.asm. First time chat from Doxus93, the real question is which one is objectively better? That's a good question. I would say neither. There's probably a way better assembly syntax that doesn't look like either of these. Okay, instruction not supported in 16-bit mode. That's right. NASM, for some inane reason, is by default not in 64-bits mode, and you have to do this, right? Do I have to write just bit 64, or is it in the square brackets? I never know. Saraid says, I prefer Intel syntax because I don't want to type percentage and dollar all the time. And I prefer GNU syntax because it's more clear what each thing is, and there's more distinction between the things. Bit 64, you can do -L. Yeah, I'm not doing that because, Saraid, I'm not generating ELF files. You are right, though. That's a hack you can do to get around it. Anyways, we are now compiling 64-bit assembly in NASM, and we just do our simple main, and you can see that I'm pretty sure it made a.exe. Did it make main? What is main? That's a COM executable for DOS. Okay, and I'm sure if I run main, does it work? Main is not an executable file. How do I run a COM executable? What has NASM created? So I'm just going to use NASM and figure out a little bit of help. What do I have? Yeah, that's not going to work, but can it really? Okay. CodeView 8 Plus. I don't know what this is. Oh, this is debug. Okay. I was wondering, I'm like, am I insane? What is this? How are these executable formats? These are debug formats. You should really read what you're, reading. This, the default is a flat raw binary. Okay, this is why I don't use NASM. The default is a flat raw binary. The obvious use case. The obvious use case. Who needs symbol tables and all that nonsense? Yeah, who needs... Oh, that's so dumb. Okay. We'll select a format. So with NASM, this is how you write it. I'm pretty good at that. I can write NASM. Apparently I can't use NASM. Just point it at the file and say, CPU go, Lamau. That actually would work. What is Macho64? That's Mac OS, because Mac OS uses the Mach-O object file format. So this is a Mach-O 32-bit. This is a Mach-O 64-bit. Win64, let's do it. So we consulted the help. It told us what to do. And basically, we just need Win64. And now you can see, hopefully, is main still... Okay, let's remove main and try it again. So it didn't make main this time. What did it make? Did it make main.object? That's probably what it made. And if we look at main.object, you can see that it's a cough object file, not stripped. And then all we have to do is again use LD, because remember how we used as to compile before into an object file, and then LD to link it? We now used NASM to compile the assembly into an object file, and are using LD to link it once again. So all we should have to do is that. And then remove a.exe, just to prove this is happening. And you see it's back. I did it. Now you don't need the bit 64 anymore. I think I may still need it. We'll see. I think it's worth it to keep in there for people that have sensible defaults. And it also says, hey, this is 64 bits. What is $? That is basically a little... Is there like a help on that? No. Didn't work. I tried. So $/ or $? Rather, is just a shortcut to access the last status code of the program that was run last. So if I, for example, run ld main.object, Terrific Table says, so I better not use NASM. How come? NASM works great. We just compiled and linked an object file into an executable, and then we made blub blub like that. $? Is a built-in shell variable, so maybe there's a note on that in the man page for bash. If this was bash, that would make sense. This is eShell. You can probably do Control-H-I and then search for M to do the eShell. And then, oh boy, what is it in here? What is it in here? Maybe commands? And then built-ins? Here we go. So this is the info node for built-in commands if you really want to look at the documentation for it. And there's a bunch of them. But you can see that $? Contains the exit code of the last command. If the last command was a Lisp function, it is 0 for successful completion or 1 otherwise. If eShell Lisp form nil is failure is non-nil, then a command with a Lisp form like command args that returns nil will set this variable to 2. So that you basically can tell, did the Lisp form return 0, did it fail to run, or did it return nil, etc. Hopefully that makes sense. But yeah, it's a built-in shell variable. It just accesses the last exit code. In where am I? Okay. on God. Okay. In new shell, for example, what was I just talking about? Yeah, in new shell, if I were to run a.exe, you can see I've done this before, then the way to do it, because this is a different shell, would be to access the environment last exit code variable. And then you can see that also returns 69. Isidiush says, ah, thank you, it did. Beautiful. But in any shell, it may be different. So then that is some basic assembly, right? And we could really have this if we wanted. And it's best practice to keep that. Is it like this? Does anybody, Saraid, you use NASM more. How do you do a global? Is it like this? I forgot. It doesn't go here. Do I have to type full global? Just like that? It's probably just like that, would be my guess. I think it's just global main. Okay. So here would be a basic program that returns 69 in NASM. Here's a basic program that returns 69 in GNU assembly. And now let's try and add two numbers together, right? Let's just do some basics. So we're still going to have to move something into racks. But instead of moving a number that we know into racks, we would like to move the result of an addition between two other numbers. So one thing that we do know is that we want to store two other numbers. And for that, there are definitely rules to which ones you can and can't use. For now, we're just going to say, we're going to use RBX, RCX, and RDX for our stuff. This shouldn't be a problem. It really shouldn't. But it may become a problem at some point. Zarias says 69 in decimal, right? Yeah, this is in decimal. So I also can't link the output of as ld input file a.out is the same as output file. So a.out on your system, if you use GCC, will be an executable if you're on Linux. So make sure to do like I did, check out what your a.out is with file. If it's an object file, then you need to link it. But if it's an executable, then you can run it. And if you use GCC, right, made with gcc.exe, remember, then you can see we can actually do file made with GCC, and it's an executable already. Vimi says, huzzah! How's it going? Terrific table, let me know. It's a ELF 64-bit LSB relocatable. Is that all it says? It doesn't say object file or executable. If it's ELF and doesn't say executable, then I would say it's most likely an object file. But I don't know. Can you do object dump on it with -x? Let me know what the output of that is. I'm very curious. Because if it's a ELF 64-bit least significant bit relocatable, Vimi says, what are you working on today? Nothing. We're just going through some basics of assembly and how to, for example, add two numbers, which we're about to do. So let's move 34 into one of our registers. Just RCX we'll choose. And then we'll move 35 into RBX. We'll actually do the opposite, just so it goes B and then C. Why not? I sent it in the Discord. Okay, well, check it out. File format ELF64, .text main. That looks exactly like what I have, right? It's an ELF64 x86 64 object file. It has symbols, sections. There's some GNU property thing. How did you compile this file? Did you use GCC or did you use as? You used as, it looks like, based on your earlier thing. If you used as to do this, then you should be able to just do LD and feed it the a.out. Unless your LD is, for example, not trying to make, it's not properly parsing the architecture header of the ELF file, but it should be able to do that. So keep it coming, let us know. Hi Zarias, thanks for joining the Discord. I really appreciate it. Anyway, after this, we can add two operands, and I would like to add rbx and rcx. And what you'll notice, which is kind of confusing, is when you add two numbers, 34 plus 35 equals 69, right? Well, there's three numbers here. Don't you have to do ld-lc? Oh, you probably do on Linux, don't you? Okay. Yeah, that's... but then it would just complain about it not being able to actually link. What did it complain about? Input file is the same as output file. Interesting. That sounds like you're feeding it an executable, but I don't have that exact error, so I'm not sure. I would definitely try Suraid's suggestion of linking with, okay, perfect, ls main.s as main.s, ls a.out main.s file. It's a relocatable x86-64 sys5 object file, I would presume. ld a.out, input file a.out is the same as output file. Okay. You're trying to link a.out. That is how it works. As should generate a thing. Oh, is it an a.out format? Is he actually in a.out format, Suraid? Is that the default on Linux? That can't be. Okay, so what we're talking about, yeah, is as has, where is it? Where is it? It's got to be somewhere here. We probably don't need to do that, but what are we looking for? Doesn't seem to be here. What are you looking for, Vimy says. GCC gives me the same output. Well then, GCC would generate an executable. As by default produces an a.out. So on Linux, is that not an object file that you can link, but not an executable? Exactly, then you need to link a.out, the object file, into an executable. Pretty sure? Maybe wrong. I'm not familiar with Linux. Vimy, I was looking for the formats of as that there is. Just trying to give this guy a, instead of something other than a.out. Vimy says -o I think is an option to change name from a.out to something normal. And the linker's output file is also a.out. Oh! Okay. Suraid, bless. Vimy, bless. I now get it. The linker refuses to overwrite the object file it's linking with the executable. Yeah, so it's just a file name issue. As is generating a.out. So what you have to do is say as main.s dash, I can't speak, as main.s -o, and then just do object.out or object file.o or obj.o or o.o. It really doesn't matter. You can name it whatever you want, but just name it something, Terrific Table. I'd suggest rename to a.exe, Lamau. If you're on Windows, pretty sure he's on Linux. Okay, Terrific Table, I know exactly how to solve that one. Terrific Table says next error, cannot find entry symbol underscore start defaulting to an address. And Zarias, we're using as and LD instead of GCC, just as a learning exercise. Vimy says object file naming convention. So Terrific Table, the reason you're getting that error is that that's actually now a proper linker error, and it's saying cannot find entry symbol underscore start. Underscore start is where the C library usually initializes. So, and main is what the C library calls. So what you should do, Terrific Table, is with LD, when you are linking your a.out or your object file, whatever you've called it, o.object or o.o, whatever you want to call it, when you're linking that, pass in the flags -lc, and this will actually link with the library, remember as we looked earlier, with the C library, and by default every system has a C library, pretty much, and if it doesn't, it's not your fault. But you just compile and link with the C library, which means that your main function will be properly invoked and you don't have to write an underscore start function instead. You can see that I have a different system. I'm using tdmgcc, which by default every time links the C library unless you do no standard lib. Not worrying about that. Terrific table says, so ld main.o -lc cannot find entry symbol underscore start. Soraid says, if your system doesn't have a libc, then you're probably going to get a kernel panic / blue screen of death. I would hope. Anyways, terrific table. Hopefully we can help you out. It says ld main.o -lc cannot find entry symbol underscore start. Do you have to like manually supply the entry? I know you can also do that with -e. You should be able to do -e equals underscore start or -e equals main if you really care, because that will work right now. But that means your -lc isn't linking properly, because you should find underscore start. Soraid, this is assembly. Okay, well, you'll notice we have two numbers here, and we add them, but where is the actual result? Because we just feed it two numbers. Where does the result go? And the result, this is the tricky part, goes into the destination operand. So this destination operand is both a number that we are adding to, and will then contain, after this instruction, the result of the add of these two numbers. So RBX remains unchanged, and RCX now contains, hopefully, 69. Whatever was in RBX and RCX is now added and summed. Then we can move RCX with a register-to-register move into racks. And what you'll notice, actually, is we could directly store into racks by changing one of these, and we can eliminate two moves. Look at that, optimization. And with this program, what we do now is the usual, where we can do as main.s, ld, a.out, and then /a.exe, and echo our exit code of 69. Look at that. Look at that. Terrific Table says, I mean, I'm using a Nix shell inside a Docker dev environment on a Windows installation that crashes every time I try to play a game. Yeah, that could be part of it. That could be part of it. Vimy at Soraid. Also, Musil has a standard GNU CLib API, so theoretically you can compile everything against it and it should all just work, TM. So that's how you can add two numbers. Now, don't get tripped up if you're writing Intel, because guess what? It's backwards again. So we then need to move RBX with what, 34, 35, add racks and RBX, because in Intel syntax, the destination operand and source operand are switched. So the add in Intel syntax like this, RBX remains unchanged, and RAX contains the result of the add of racks and RBX. And we can prove that with a little linky-do. Remember, I just did the wrong thing. And what I would actually like to do is NASM. Here, can I do like... where's NASM? We'll just go find it. There it is, -fwin64. That's what it is. I always forget. And then that makes main.object, and we can do -link main.object provided from our NASM compiler, from our main.assembly, Intel syntax x86-64 assembly. And we'll just do nasm.exe. And then we have nasm.exe, which again, probably a horrible idea. I'm going to delete it right after this. But you can now see that that also produces 69. How about that? How about that? How about that? There's so many chats. Okay. So that's cool. Remove ./nasm.exe. Okay. Remove main with gcc.exe. Remove everything pretty much. a.exe, a.out, main.object. Okay, back to just our assembly. So that's how we can do like the very, very basics of assembly. If you really wanted, you could also make these executables smaller, right? So you could do a little bit of work, and instead of linking with libc, because we don't use libc, you can actually just make a program that basically directly interacts with the OS, and you can make your own start. I don't recommend doing this, but if you are not using libc, this means you can make a very small executable, maybe a kilobyte, for large programs. Not really recommended because also you're going to have to make this global underscore start and everything like that. Main is good if you're writing user space programs because main is basically where every user space program that's currently running initializes. So keeping with the convention is a good idea. Okay. Let's do a little bit more, and let's do libc, right? And what I'm going to do here is a similar thing. I'm going to have global main, right? And then ret. Make sure to always have ret. Now, when we get into libc and interacting with libc, it gets a little bit complicated because, here, let me bring up this right here. sys5 calling convention. An OS will define a calling convention that it uses for the programs that will run on that OS. And basically, let's do this one. Basically, there's a lot of calling conventions, but most of them have to do with these two right here, which are these two companies really pioneering them. And the x64 calling convention for Microsoft is that the first four arguments are placed into registers RCX, RDX, R8, and R9 for integer, struct, or pointer arguments, right? For floating point arguments, use the floating point registers. We don't talk about those right now. Okay. No abstractions such as data types. That's correct. There are only numbers. Vimy is recommending books. Isidiush says, thank you, I'll get it, so hopefully I'll understand and help you all hear all. It's all good. We'll be good. Whatever we can do to help you. Suraid says, Lamal, Lens is the one with the custom keyboard firmware, not me. That's true. I compiled my own custom keyboard firmware and flash it onto my split keyboard. It's fun. And with these volatile and non-volatile registers and caller and callee saved, this is stuff you are going to have to know if you want to call libc and stuff from assembly. So reading up into the calling convention specifically for your OS is a good idea. And this is Linux and this is Windows, if you couldn't tell. Now the calling convention also says that we kind of need a stack frame for each function, which means that our assembly needs a bit of a stack frame. So we need to push the base pointer, which this is saving the stack frame, the base pointer of the previous function. Then we move the current stack into the base pointer, right? So this basically says whatever the current stack pointer is, move that into the base pointer that is now our stack frame, right? And this is, again, just moving a number into a number, right? Just places where numbers can go. And at the end of the function, because we have pushed something, we should then also pop RBP, and we will pop it into the same spot as we pushed it from, which means that this restores the value of RBP at this time, which means that our previous stack frame will be restored before we return, and that will do the proper thing. When you call a function, that is done with a call instruction or mnemonic, and call pushes the return address of the function that you actually need to get to. So after this, what's on the stack is actually the base pointer, and then above that is the return address to the function that ret will jump to. So ret also just pops off the stack and jumps there. Very cool, huh? Zaria says, wait, might be too broad of a question, but how do you even do keyboard firmware? Well, you need to run it with // possibly. That's definitely it. Sarade. First time chat from Shadowprof. Strange error on Linux. After linking, I get an executable, but when I try to run it, Bash says no such file or directory. If you have an executable called foo in the current directory, you have to do /foo. That is true on Linux. What was I looking up? I don't know. Anyway, we now have a function entrance and function exit, right? Sorry, am I forgetting something? I feel like I'm forgetting something. By the way, file also says that it's an elf. Elf is okay because just like cough, it can either be a executable or it can be an object file. Sarade says keyboard firmware. Oh my god, you're amazing. Thank you, Sarade. I totally forgot. QMK. So QMK is probably a place to start if you're actually interested in the firmware itself. QMK is a keyboard firmware, quantum mechanical keyboard firmware, right? Has nothing to do with quantum mechanics, but it's a cool name, ain't it? And these is what pretty much every keyboard in existence supports. These are all the community keyboards that have been added and are supported by QMK. And what you'll notice if you scroll down to H is right along here. There's bugs in this firmware. Don't use this one if you have this keyboard. Just so you know, contact me. I'll give you the right one with the proper patches so that RGB lighting works. But I'm working on getting it merged. It's just they're very strict. This firmware, basically, you specify what your keyboard is like and key maps that you want, and then, for example, via keymap.c, and you can see you basically have a data structure, which is a layout with all these key codes that are then an Arduino will send to your computer, and your computer will go, oh, key code 3, that's a 3. We'll draw a 3 on the screen. Shadowprof says ./a.out results in no such file or directory, so it's kind of weird. So if you do ls, a.out shows up. And then if you do ./a.out, you get no such file or directory. While ls says that it's clearly present. Yeah, that's okay. Okay. That's really odd. Zaria says, okay, we'll check QMK. Yeah, and basically, I have my own fork of a QMK firmware, if you want to check it out. I can't remember. It's in here somewhere. Here it is. I have my own fork, which has my own branch for my actual keyboard. And you can see it's been a while since I've updated it. Not even that long. But there's lots of commits on these ones. Lots of commits. So yeah, there we go. As far as calling conventions, these are calling conventions. And what you can see is that we're going to have to interact with them. All right, Sarade, if I forgot something to do with stack frames, let me know. But I'm going to continue and try and call a function now. Hopefully it doesn't go too badly. One thing about calling functions is they need arguments, right? So a calling convention will make it... What have I done? Where did Emacs go? Is Emacs not there? Hello, Emacs? I don't want Discord. Emacs? Emacs isn't on the left here. Okay, just checking. Anyway, not going to worry about that. Anyway, Integer arguments are passed in registers RCX, RDX, R8, and R9. Remember, this is from Microsoft, and on Linux, you're going to have to follow a different calling convention. You're going to have to look it up. Which one does your system use, right? Figure it out. And then most likely it's going to be, if you're on Linux, System 5, because this is used by Solaris, Linux, FreeBSD, macOS, and all Unix likes. And this has this argument register layout. So instead of where I would use RCX, RDX, R8, and R9, you would use RDI, RSI, RDX, and RCX. Okay. So let's call a libc function putchar, right? And by the way, Shadowprof, I have no idea why that's happening. I would love to help you out. If you have any more data, I will try and figure it out. Be sure to ask in the Discord too. I'm sure there's more people online than are watching here. Putchar is a basic function. This is a horrible website. And this prints out A through Z. We're not going to do that. That's a little complicated. Sir Aid says, is the file executable? Oh, you might have to do chmod. That's true. That's true. That'd be weird, but that is true. So this is passed as its int promotion. Putchar takes in an integer. Remember, integer arguments go in these registers. And it will write it to standard out. So ideally, we should just be able to move a character, some character, right? Let's call it C, into our first argument register, because there's one argument, and that argument is going to be RCX. And we'll say first argument to putchar is an integer, right? So Windows RCX, and on Linux, you would actually, we'll call it Unix, on pretty much everything but Windows, you would use the other calling convention, which is RDI. Yeah? Okay, hopefully that makes sense. And then C here, remember dollar is followed by numbers only, so we need a number here. So let's do 69 once again. Why not, right? 69, if you don't know, in ASCII is a capital E. So hopefully this will print a capital E after we call putchar. And then, because we want to return success, we're going to move 0 into racks, because we don't want to return whatever putchar returns, we want to return 0. Hopefully that makes sense. And with this little program, we should now be able to do a little bit more. Libc. And you can see that we have just main.s. Why did we move RSP into RBP? Okay, good question. Good question. That's something I've done for so long, I never question it. Step 1 would be alignment, okay? Is it Eyyy? Most structures are aligned to their natural alignment. Primary exceptions are the stack pointer, right? Stack pointer are SP and base pointer, which are 16-byte aligned to aid performance. Alignment above 16 bytes must be done manually. Since 16 bytes is a common alignment size for floating point operations, this value should work for most code. Then it says if you want to see more about it, look here. And if you look here, you can see that basically there's a bunch of specification about it, but the stack will always be maintained 16-byte aligned. And what this means is that if you call a libc function and your stack is not aligned to 16 bytes, there's a big error. Yeah, Sir Aid says aid performance is an understatement. It may crash horribly if it's not aligned. Yes. And basically, it will not work. So what you have to do, if you remember when we call something, the call instruction, remember you can look up the software developer's manual to look more into the call instruction. Oh God, don't even remind me, Sir Aid, don't remind me. I'm getting flashbacks to Lenser OS. I hate it. Aligned instructions. Is it Eyyy says, oh, can we try it? Yeah. I like your thinking. I like your thinking, Isideush. So remember call, I'm going to get through this thought first. Call pushes the return address. The return address is the register RIP, which is not a general purpose register. It is the instruction pointer and refers to the memory address at which the CPU is currently executing code, opcodes. And where that is will be RIP will be pushed onto the stack here so that we can then later with ret jump back and we will be executing this, the next statement. It will basically add one instruction to the instruction pointer, push that so that when you return, you continue right on here. So call pushes the 8-byte return address onto the stack. So if we don't push anything, then what happens is the stack, although we can create a stack frame and pop it and everything works fine that way, so we could have local variables and nothing would break. The problem lies in the fact that when we call putchar, the stack will be 8-byte aligned instead of 16-byte aligned, and bad things will happen. Shadowprof says moving and pushing RSP and RBP are called prefix and suffix. There's a lot of names for it, but yeah, you could think of it like that. There's a function prefix, which is setting up the stack frame, a function body, which is what the function should do, and then a function suffix, which returns and cleans up the stack frame. However, these aren't needed for every function, and there's a lot of crazy stuff you can do with compiler optimizations. We're not going to talk about it. Nashiora says, I've heard prelude rather than prefix. Sarade says prologue and epilogue typically. You can call it whatever you want. There's this initial section, a middle section that does a lot of stuff, and then an end section. I always get confused which one's pro and which one's epilogue, so I don't use those personally, but I should. It's just that I'm too nonsensical to actually do it. So with this should have an unaligned stack and should crash horribly. So let's try. Because we're linking with libc, I'm just going to use GCC, which is by default links with libc and makes things easy. I don't need a -o here. Then you can see it builds, and then I can run a.exe, and you can see that there is some time there for a very simple program, and we didn't see. You know what we didn't see? We didn't see E get printed out. Why didn't we see E? Why did it return 5 when it should return 0? This is because the stack is unaligned, and this is horrible, horrible things. Isideush says, so we got a 16-byte align every time we do something with functions, guys? Sort of. You can ensure as a programmer, because when you call a function, it needs to be 16-byte aligned, and it's ensured that it is 16-byte aligned. The call instruction pushes 8 bytes, which means that it is then misaligned at the beginning of a function, so you need to realign it to ensure that the next function call will also be aligned to 16 bytes. Otherwise, everything breaks. Hopefully that makes sense. It's already in exe, but bash is blind for some reason. That's really weird, Shadowprof. That's really weird. Anyway, if we then, all I did was uncomment that line, right? You just saw. We rebuild it. We rerun it. Oh, it still crashed. I did something wrong. That's okay. What did I do wrong? Let's think about it. I could do section text, so I need to do that. Something like that. Just trying things now. That still didn't work. What did I forget? Sarade, what did I forget? You're clobbering RSP. No, you're right. The move is there. I was gonna say, yeah, we should be okay. We have push RBP, move RSP RBP, move 0 racks. So let's try and remove the call and make sure that this program just works without going crazy on it, because it may just be the thing that GCC is not doing the correct thing. Okay, so we can return a number. By the way, this is usually how using libc from assembly goes. We can return a number, so we have a basic program, that's good. We can move into RCX. Maybe, is RCX volatile? Anyone remember? Volatile? RCX are considered volatile, aka caller saved, so we don't have to save these ourselves. RAX, RCX, RDX. We're not doing BX. Should be fine. RCX is volatile. Yeah, we're good there. Maybe I'll just use Discord so everyone can see. That's an amazing idea, Shadowprof. Well, here we go. Our first little issue. And we can do everything except... This still works, right? That still works. But when we try and call putchar, that is when things go horribly wrong. Which is interesting, because putchar is just a function from libc. We could look at the disassembly if we really want. It returns an integer into rax, which we then overwrite with 0. Standard out. The parentheses with return is so cursed. So you would think, why is there like CPP reference? Just making sure. So, interesting. Maybe it's not just putchar. What? Maybe underscore putchar or whatever. Well, that's incorrect, Zarias. I do understand where you're coming from. We would be getting a linker error if we couldn't properly resolve the symbol putchar. And I guess we could do something like this. Can I do... Is this how this works? I don't remember how it works. Let's look at just this. What is it? It probably didn't generate anything, so we're just going to have to do the executable. Yeah, there's lots. But we can see that we're linking with libc. But there's no putchar, which is interesting. Is there an underscore putchar? There's not an underscore putchar. Lots of stuff in this executable. Lots of symbols. Entirety of p thread statically linked. Okay, Minji W. Sorry, it says -d main. Bless. I always forget what it is. That'll help a lot. Yeah, that didn't work. Shadowprof says, post it and help me. Because -d just does disassembly. Is it -d? -d equals main? I mean, it just said it doesn't equal a thing. It doesn't work. Or dash disassemble. Oh, there you go. It's -- disassemble. Okay. So this works, obviously, because I forgot to recompile it. That would be step 1. I was like, wait, that makes too much sense. Okay, here we go. We are calling putchar with a value of OX45, which is 69 in RCX. We move 0 into rax, we pop RBP ret after moving as we push. Well, that's a curious one. That's a curious one for sure. Because putchar just requires, it doesn't require a pointer or anything, it just requires an integer character. So it says, oh, I see, we're both stupid. Yes, we are. What did I miss? I've been asking you this whole time. What did I miss? Is it with function entry? You have to move RBP RSP. Before pop RBP. Oh, Lamau. You sort of have to reset the stack pointer. Yeah, I remember now. Oh, Windows, why? And the dollar. Okay, hear me out. So the base pointer refers to the stack pointer when we have just pushed the base pointer, the previous base pointer, BP minus 1, right? So base pointer refers to the address basically of BP minus 1. It has nothing to do with Windows, that's a general thing. Yes, but also no. Putchar should return the stack to where it was. That's my opinion. Basically, what's happening is this base pointer refers to the base pointer minus 1, where to find that. And the stack pointer, when we call putchar, I guess isn't being returned exactly to where it was before, so we're having all sorts of issues. Unless I'm mistaken even further. I am very often mistaken. So what we have to do is set the stack pointer so that when we pop RBP, then it actually is this pop RBP and not another one or anything like that. So this just pops RBP from the stack pointer, which the stack pointer we saved right here, which has the base pointer. Hopefully that makes sense. I knew I was doing something wrong. Oh, that's what you mean. Yeah, that is a bit weird. Exactly. Because we don't alter the stack. It's not a big deal. It's putchar's fault. It's Windows. We can now, hopefully, have it error some more. That's my favorite part. With an access denied error code. When in doubt, it's Windows that's at fault. That is true. That is pretty much the thing. So I could try writing the same thing in NASM and just seeing what happens. It won't be hard. Global main, push RBP. RSP, RBP. Move 69, RCX. RSP, RBP. 0 into racks, RBP. Probably do this. It doesn't matter. We're not altering it. Push the base pointer. Move the stack pointer into the base pointer. Move RCX 69. Call putchar. Move racks. Oh, Sir Eyyy. Oh, Windows. Oh, okay. Sir Eyyy, I fixed it. Sir Eyyy says also, this is why we have high-level languages. Assembly programming pretty much always goes like this. That is 100% correct. This is every time you open up and try and write something in assembly, you get errors like this and are like, what the hell is going on? Sir Eyyy, do you remember that little thing in Lenser OS in Start that was kind of making things break in user space in your testing thing? Because that thing that we really didn't account for, right? Ugh, I hate this so much. Where is it, man? Somewhere here. It talks about needing... Okay, here it is. Okay. Sir Eyyy says, oh no, that nonsense. Yep, that nonsense. I remember now. That's so dumb. Sir Eyyy says, oh no. Chat, has anyone figured it out? There is something called shadow stack space that we need to provide on Windows. I feel like a magician. When in doubt, it's Windows that's at fault. Case in point. Is it you says, what the heck? Yeah, so by the way, I totally forgot about this. I'm going to go back to writing what I know, GNU assembly. Oh, so basically, putchar, when we call it, assumes that on the stack, where did I just go? It assumes, even if the called function has fewer than 4 parameters, like putchar, these 4 stack locations are effectively owned by the called function and may be used by the called function. So, on our stack, I'm so mad. On our stack, we need to make space for 4 integer arguments, which is 32 bytes. I get so mad. And now, I would hope... Oh! Look at us. Look at us, chat. Look at us. We got an E. Okay. This is why you don't program in assembly, by the way. Woo! That sucks. I've started to dislike Windows. I mean, there's similar things when you get into, like, the red zone on Sys5. It's all bad, I promise. Saraid. Oi, listen to this. What if we just store local variables in the stack frame of the caller? Genius, right? It's true. That's what they do. Oh, it's so dumb. Okay, there we go. That's good that we've done that. So now we can call putchar. And now that putchar works, we can call it with all sorts of things. Like 121 and 10. Anyone know what 121 is? You know what it's gonna print? What's it gonna print, chat? What's it gonna print? Eyyy! Eyyy! We did it. Eyyy! How about that? How about that, I'm gonna turn off display line numbers mode. The red zone is implied to be below the stack pointer, which is something you shouldn't really be accessing otherwise, so not using it, supporting it is just fine. This, on the other hand, will horribly crash your program. You're right. I may have just spilled some tea on myself. Is it a use? Says red zone on Sys5 sounds like a bunker with infected zombies. That's awesome. So we wrote an assembly program that says, Eyyy, how about that? How about that? Now, you'll notice that putchar is simple enough, right? But what if we wanted to like print A more than once? How would we do this? We would want to extract this into its own function that can be called multiple times with multiple registers, right? And to do that, we can just create a local function anywhere in the file, really, and we'll just call it Eyyy, right? And this function is going to be a function much like main, so it needs all the things that main does. This is only if you would like to call Eyyy from somewhere that is not, right? From somewhere that is not right here. And you would also need global Eyyy. However, Eyyy, if we know that it is only a local function, then we don't actually need this prologue and this epilogue or these stack frame things. We can just basically, because we call putchar, we do need the stack frame things. But if we didn't, what we could do is call A, we'd have to push garbage, like push RBP so that we're once again 16-byte aligned. Then we could call putchar, and basically with all these arguments, and we could basically just extract that into its own function. Right? And then we could just call Eyyy. But again, we'd have to push RBP so that there's something on the stack, just garbage. We could also sub 8 RSP, right? Just make space on the stack for aligning it once again. And then we also would have to, yes, add 8 to RSP here. I love how push garbage is literally a comment in libc, Lamau. It's true. We get more failures. That's fun. And the reason for this would probably be some stack nonsense, wouldn't it? Yeah, because the return address is being overwritten by the stack. So we'd have to sub like 40 here. Because we need the 32 bytes and then also... Eyyy, there we go. And then, because this is a local function, we can just call it a bunch of times, and it's not a global. Eyyy. Okay. However, do take note, if you tried to call Eyyy, if you tried to make it global, so that you can link with it, right? And then you try to call it from another language like C, well, the calling convention assumes that you're doing this stuff, and because we're not doing that stuff, it would break horribly. So don't try and do this if you're gonna try and make the prologue more efficient by not doing what you don't need to do. If you don't understand what you do and don't need, just copy and paste the default epilogue, prologue, whatever you need. Isidayush says, Eyyy. Isidayush also says, do we need to clear registers before reusing them? Yes. Yes, you do. Because when we move 10 into RCX here, we're overriding this 121 in RCX, which overrides this 121, which overrides this 121, which overrides this 69. So we could even call putchar on Y with the same argument 3 times in a row, and the same thing will happen. Why do we get diacritics? Oh, this is actually great. I know why we get diacritics. We get diacritics because if we look at the calling convention, the registers RCX are considered volatile caller saved. This means that the caller, we are the caller here. Eyyy is calling these functions. It means that RCX would need to save it if it wants to use it in between function calls. So we'd have to push RCX and pop RCX to properly save RCX in between these function calls. Hopefully that makes sense. Otherwise, we can just move 121 like that and overwrite it instead of saving and restoring the one value. Zaria says it's not padded, as in if we only write to the lower nibble, for example, the higher nibble is not zeros, right? This is moving a 64-bit integer literal into RCX. If we were to move into ECX, this is the lower 32 bits, and you are correct that this extended C register, it wouldn't really, the top bits would still be set to whatever they were. But most of the time, with move and a constant literal, you are using a 64-bit integer literal to set a 64-bit integer register, which means that it maps 1-to-1 and you're good. Okie doke, okie doke. We're doing good. We're doing good. Isidayush says, hey, now we go to operations. Sorry, it says also lends 32-bit operations 0 the upper 32 bits. Does it really? Like move to EAX will clear the upper half. Oh, so it's like if we move to CX or CL, that's when the problems come in? There's so many little things like that. Sorry, it says yeah. So basically, we didn't talk about this because it's a little complicated, but there are more registers than just the 16 general purpose registers. Okay, so that's calling libc from assembly, right? So now let's do library. Let's do another example, shall we? And in this example, we're going to have more assembly. What do you know? We're going to have a global main, which is an identifier, or a label, I should say. which returns, remember at the beginning, what do we need to do? We need to push the base pointer of the previous stack frame. We need to save the current stack pointer as the current stack frame into the base pointer. So we need to move RSP into our BP. And then, because this is Windows, we need to sub 32 from the stack pointer to make space for allocations. Then we need to move the base pointer into the stack pointer so that we can properly pop the base pointer off of where we pushed it from. And then we can return, and then we should also set the return value to something like 0 to be sensible. That's a hash, not a dollar. There we go. Sraid says, this is why MASM is such a mess. People got tired of the shadow stack nonsense all the time. It's true. First time chat from Red and Blue Makes White with exclamation point setup. What are you trying to ask, Red and Blue Makes White? I don't really have a Twitch bot here. Isidiush says, someone needs to make a notebook and pass it along. I mean, it's called the Intel Software Developers Manual. It tells you all about how the hardware works. The actual, how the assembly works, that is less documented, I'll admit. Zaria says, maybe your dot files. Those are available on my GitHub for Emacs. What is your setup? It's a setup. I'm getting got. I gotta run. It's a setup. I don't know what you're asking about. Red and Blue Makes White. Okay. Now, in this, we can write a main function, right? And it will execute whatever's in here. And as before, when we called putchar, right? You can call functions that aren't defined in the same file as long as you link with them. So what we could do is have main call greet. That's it. It just does a greeting and then exits. Pretty simple. And then we could have greet.s, right? And in greet.s, we have a global greet, which is greet. This just means, if you don't know, like to say hello. And we are going to, because it is a function, we want the full calling convention for our architecture or OS. Remember, this is different if you're on Linux, very slightly. You just don't need this, really. And in greet, let's just have it say what we did before. We're just going to steal our code because we're smart programmers and we reuse our code when we can. And there you go. So then we have should print Eyyy, right? And with this greet.s, how do we make it so that main.s can actually call greet? Well, let's do what we were doing before and see where it goes wrong. We're in library, right? Here, let's make this a little... Okay. We're in library, and you can see we have greet.s and main.s. So if we just do gcc main.s, oh, it didn't work. It says, looks like there's an error. There's a lot of random stuff. This looks like a file path. Oh, it's a file path to LD. So the linker had an error, it appears. There's another file path to a temp object file. So whatever GCC compiled the assembly into an object file, that worked. But when we were trying to link this temporary object file into an executable, there was an error. Undefined reference to greet. Huh. Well, that's right there. That's why is it an undefined reference? Well, we reference it here, but there's no definition. It's the function isn't defined, so it says you can't do that. LD returned 1, you can't make a program. So what we can do, by the way, what I could do is also use as and then LD on what it generates, and you can see we get the same error from LD. Yeah. Straight says rip. Oh, that error was intended, I see. That is correct. So you can see that when I can never quite tell when it comes to linker errors, haha. It's true. They're confusing sometimes. Doxis93 scripted stream. Scripted. I love the idea. I'm just sitting here reading from a script. There's a video playing. I'm not even like typing on the keyboard. It's all fake typing keyboard sounds. I'm not even doing anything. I'm just reading from a piece of paper. Scripted. Red and blue makes white. All vids out there on YouTube are scripted. Suraid, plot twist. It's not even live. Everything is pre-recorded, even chat. You are being pre-recorded right now. Is it Yush? Lens reveals he's Chat GPT. I actually... It's so accurate. I say things in way too many words and get them a little bit wrong. Like, it's perfect. Red and blue makes white. I am a part of the script. Oh, this is getting meta. Nashiora, cut this out of the script before you record it. Okay, so there's an undefined reference to greet. Is it a huge Matrix moment? Oh, I love that. So I'm going to use as because as didn't fail, if you remember. As runs. So we then get a main.object. And if we take a look at main.object, it's just an object file. Everything's fine. We can object dump and learn all about it with -x. And go, oh, it defines main. And if you'll notice, there's some different qualifiers here, namely this one, which is greet has a 0 value and is undefined. It's in the undefined section and needs a relocation. Sorry, object dump prints an extra space, shaking my head. It's true. It's really annoying when programs do stuff like this. It's like, why? Ugh. At least at the prompt, it makes sense. There has to be a space there. Anyways, there's a relocation record, and it says, hey, at offset 9, this number right here, in the symbol table, there is an relocation, which is an AMD 64 32-bit reloc. Don't worry about what this means. Basically, it's saying that greet is some symbol that needs to be relocated, which means that this address isn't correct, and LD needs to have an address for this symbol and locate it there, relocate it there. And to do that, we need to pass LD an object file which defines greet. And to do that, we can build greet.s into greet.object. And that works as well. Now we can do object dump -x, greet.object, and you can see it also has a similar thing with relocation records because it calls putchar. And putchar, well, that's not defined in greet, so that has to be relocated by the linker, right? So all of these things, by the way, this is the offset within the actual code that it has to write the resolved address to, rather than the offset within the symbol table. I was incorrect. I forget. There's so many numbers, so many numbers. But as you can see, we now have two object files, main.object and greet.object, and we just need to link those together. And to do that, remember LD takes any amount of files, undefined reference to putchar. That's an interesting one. So we need to link with the C library, which isn't going well. Remember, it's options then. So you'd think undefined reference to putchar. So maybe we need to... Any ideas? We could also just use GCC to use main.object and greet.object. There we go. Remember, GCC is a compiler driver. It just is a collection. Isidish says, did we compile? We did. Main.object and greet.object GCC made a.exe. You can do GCC-v to see what it actually does. That's a great tip. Thank you. I should have been doing that this whole time. Well, I shouldn't have. It's a little complicated. Ah, yes, the classic Windows libraries. Okay. Yeah, I'm getting it now. So it's calling right here. Oh man. It's calling collect2, which is calling libLTO. We don't want to worry about that. We don't want to worry about that. Yeah, so we don't want to worry about any of that. -v equals short? Yeah, that is a good idea. It doesn't work. They should implement that, though. Red and Blue Makes White, thank you so much for the follow. AJ1228, thank you so much for the follow as well. But you can now see that we have an a.exe, and it prints Eyyy. Look at us. Because GCC links with libc by default, which was the error. By the way, I'm pretty sure I just thought of the solution. Okay, it's definitely that. I'm pretty sure. But we could also do. Yeah, it's just freaking out. I have the wrong LD, I think. Where is LD? Yeah, look at that. That's what's going wrong. We're using the Emacs LD instead of this LD, which is causing some issues. I bet you if I used this LD, it wouldn't be so problematic. Can I run that? Command not found. Classic, classic, classic. I'm going to try it. Perfect, undefined reference. Cannot find -lc, which, oh, okay. Cannot find that. Okay, that's impressive. So I'd have to do, yeah, I'd have to include the system files on my own. This is why we use GCC, by the way. So it says Lamau, yeah, using your operating system's native linker doesn't work in this case, and by operating system, I mean Emacs. Red and Blue Makes White says use Vim. Use Vim to do what? Would you like me to use Vim to look at assembly? We can. Right? Here's Vim. Boom, we did it. Here's assembly. Use Vim to link it, shaking my head. Use Vim to link the executable. I don't know how, just use it, shaking my head. Yes. But yeah, as you can see, if you're on Linux, this will work much easier, and you can just use LD, the object files, and then -lc. This will work on Linux, I promise. For us, we're going to use GCC because I have to use, again, if we look at GCC, I have to use TDM GCC, which is like built specifically for Windows and has all of that stuff done. Okay, so with GCC, we can properly compile and run a.exe, and it prints Eyyy. Oops. You can also use Clang. Yeah, that's also an option. Vim-L user 32 a.out. Yeah, that'll work. So what you'll notice here is that because we're using the object files, it didn't update from the code. So what we could do is just pass in the code directly and then have it all work out. Thanks, GCC. And what GCC is doing, again, if we really wanted to know, the -v, you can see that first we're basically, where are we starting? Okay. We include some stuff. We run the GNU assembler, right? With cc1, lang asm, quiet v, I prefix. With that stuff, reentrant greet.s. So we're calling cc1 with greet.s, which compiles it. mtune generic arch x86-64. It then does the same thing for main.s, somewhere in here, if you can find it. Right? And then it basically goes through and links all those two object files together into a, right, these two object files. They're temporary, but they're there. Then it links them with all these libraries for Windows, and then we end up with an executable. Gotta love -quiet -v, Lamau. Yeah. Terrific Table says, for me, -lc kind of works and also kind of doesn't. It compiles links, but there is no output. I'm calling putchar with 99, which is the character C, but I'm not getting terminal output. Are you moving? Okay, question, Terrific Table. What register are you moving the putchar argument into? What does your call putchar and the line before it look like? RCX. I see. You may have missed this earlier because it's very complicated. We've been jumping around doing all sorts of things. On Windows, where was this? I don't remember where this was. On Windows, you need to have the, here it is, Microsoft x64 calling convention, which uses the registers the RCX, RDX, R8, and R9 to pass arguments for integer arguments to functions. So we are using RCX to pass an integer argument on Windows. On Linux, Terrific Table, thank you so much. Yeah, we will be able to help you. On Linux, they use the System5 ABI, which has its integer arguments in RDI, RSI, RDX, RCX, R8, R9. So the first integer argument should actually go in RDI in your case, instead of RCX in the case of Windows. So by changing move99 RCX call putchar to move99 RDI call putchar, you should then see output on your beautiful, beautiful terminal. Okay. So this is pretty cool and all. We can have two different assembly files and they work together, right? That's cool. I went to the wrong one. I was like, that doesn't look right. What would be cooler, I think, is what if we could make a C file and call assembly from that? Now that would be pretty cool, would it not? So let's try it out. So much like how you need an int main, a main function in main.s, we also need one in C. And then we just have 3 calls to greet. And in C, instead of calling call, you just call greet, like so. That's it. However, let's try and compile this and look into what errors that we get. So instead of main.s, we use main.c. And it says, warning, implicit declaration of function greet. However, you'll notice it did produce a.exe, which here, I'll make it more clear. You can see a.exe did get generated after being removed. And if we run it, hey, it works. Look at that. We didn't even have to do anything. You just call greet and include greet.s as part of your call to GCC, and you are all good. Now, under the hood, remember, this all it's doing is calling basically cc, right, cc, on main.c to generate an object file. You can do the same thing by passing -c to GCC. And that will generate, as you can see, main.o. And if we look at main.o, you can see it is a object file. And then it's making an object file with as, right, from greet.s -o greet.o. Then that makes greet.o. And then it's using LD to link main.o and greet.o into an executable. Remember, we have the same thing. It's saying, hey, we can't do putchar, and I don't know what __ main is, right? And that's because we're missing all of those magical linker flags, which we need on Windows, but you don't really need on Linux. So we can use GCC, TDM GCC, to properly use those. In which case you can see it worked. It generated a.exe, which we can run. However, what you will notice with this system is that we get a warning. We don't really want a warning because we're doing something proper. So all we have to do to avoid this implicit function declaration is declare the variable. Now, you can kind of, interacting with the type system is a little rough, but Rax will always store the return, and it always returns 0. In fact, we don't even take the return value or use it or return different return things, so we can just have it be a void. Greet void, because it doesn't take any parameters when calling it, and that's it. If you're in C++, you should do extern C, but because we're in C, we can just have void greet void, call it, and look at that. No more warnings when we compile. Oh, I don't know what I'm doing. And everything still works. We can even say for int I equals 0, I is less than 9, ++ I greet. Right? So this should now greet 9 times, 8 times, 9 times, because we're starting at 0. And you can see 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 greetings. So we are calling assembly here from C. And this is only possible because we followed the calling convention and kept the stack aligned and such like that. Ain't that cool? Ain't that cool? However, you can also, if you really wanted to, Sarade says, oh god, this reminds me of that one Haskell video. Terrific Table says, the bash says the file a.out ld gives me doesn't exist, which it does. Is it executable? File a.out is an ELF 64-bit LSB executable x86-64 dynamically linked interpreter, not stripped. Okay, there we go. We did it. We can call assembly from C. And an interesting one may be calling C from assembly, which you can also do. Terrific Table says, I had this before, but I don't remember how I fixed it. What exactly is the error? It's bash file does not exist. That's just how to check. Here we go. So are you sure that the interpreter is correct? Can you use like LDD on the file? What if you tried that? Can you use LDD? Can you maybe screenshot the output of ls file and you trying to run it and put that on the Discord? So Sarade, that would definitely help us. If you used LDD, you would be able to see the dynamic libraries that it's trying to load and make sure it's going to work. So you may need to install libraries, it looks like, on some systems to be able to run the dynamically linked executable, because your interpreter is may be botched. I would try LDD to see what it says to you for the dynamic linking. What do we got? What are you saying? Seg faults, yay. Oh man. I'm so bad with technology. Okay. glibc moment. LDD a.out. Well, that looks fine. Interesting. Interesting. I'm not sure what's going on then. It seems like everything should be fine, especially if things like LDD can find it. Bash should be able to find it to run it. Shadowprof says strange -o main /main. No such file or directory main. Very interesting. I do think this has to do with, like, is it executable or not, but I could be incorrect. Hello, Shadowprof. Hello, Vapre. So, Mouse SX says, how do you have a single server on Discord? This is all I do. Try /a.out. Yeah, that'll work. This may actually help you. Only run it if you know what it does. Don't just run random things you see from people on the internet. And if you don't know what it does, ask. I'm sure we can help you. So what were we doing? We called assembly from C. And we would now like to call C from assembly. So wouldn't it be easier if, instead of having to, like, figure out arguments and stuff to putchar and what register it goes in, you just had the C compiler do that. And we would still have to worry about which argument it goes in, though. Either way, let's try it. Let's take greet and make greet.c, and this will just be a void greet. And this will be the actual definition of greet, which we'll call putchar a few times with 69, 121, 121, 121, and 10, which is Eyyy. And you could also do, because this is now C, type it out in a little bit more of an understandable way. How about that? So it says, wouldn't it be easier to just not do all of this nonsense by hand? It's true. So this is really what greet does. It calls putchar with these things. And what you'll notice is that we can now pass any combination. Okay, implicit declaration of putchar. That's a good point, because the putchar is defined in standard I/O. You'll notice that we can now use any implementation Is there a way to, like, do something no matter what? Because and will only work if it succeeds, right? Even if, is there like a semicolon? That's probably what it is, semicolon. So it's a semicolon, all right. Can we write game of life in assembly? Yeah, it's pretty easy. Not even joking. Okay, so with that, we can now run a.exe, and you see it works. And we can now use greet.s instead. And now we use our own greet function in assembly instead of C. Or we can call the C function from assembly. Look at that. Look at that. And you can see the differences because one of our greet functions greets multiple times, right? Main.c. Yeah, see this greets 9 times and the other main.s greets 3 times. Pretty cool. A or B to execute B only if A fails. Nice, okay. Okay. There we go. Well, we're coming to a close on the assembly stream unless anybody has any requests or ideas for what to write. We basically wrote everything that I could think of to write. We went through the basics. Someone, so what do you do? The computer screen, Eyyy. It's true. We went through the basics, like adding numbers and returning status code from main. We went through a little bit more complex, calling libc functions from assembly, which requires knowing which calling convention you're using and adhering to it, which is the hardest part. And then we made a library in assembly, which can be called from assembly, C, C++, anywhere you want to call it from, with this greet. And then we also pointed out that you could implement greet in C as well, and they both work just the same when you're compiling. You can use greet.s, you can use greet.c. They both work all the same. How about the? So, yeah. There's a ton of stuff I didn't even really get into, which, for example, Nashiora says personal next steps, writing the compiler backend that generates assembly prerequisites, actually finish Lay's type checker. That's a big one there. So, yeah. Writing the compiler backend that generates assembly prerequisites. That sounds fun. The cool part, for example, one thing I was confused about for a long time is how does like an interpreted language compile? Because there are things built into the interpreter that need to be run at compile at runtime, right? They need to happen at runtime. So to call those, what actually happens is very similar to this greet.c scenario, where basically there's an implementation that's separated from the program, and you can compile this implementation to its own object file, because we can just do gcc greet.c -o greet.o, right? And it'll work, except that it says, hey, we can't link it because I forgot to pass -c to actually make it properly. Then greet.o is just a file which has purely the greet implementation, which you can then link any assembly that you create with this greet implementation, and now greet is built in both into the interpreter and the compiled program. Hopefully that makes a little sense. Nashiora says, oh right, I forget people don't know my weird pronunciation inherently. I pronounce it Eyyy, and I don't know how I'm going to release it to people and have them pronounce it wrong to my ear. Gonna have to build up that tolerance early, I guess. You could also just change the name to make it, like, symbolically more clear. Like, if you put a la-yay, I know you don't have to do this. If you did la-yay, I would read it as la-yay. Or la-yay, if you want to backtick, or even an underscore, I may read that as lay. You can add an IPA transcription. Ah, yes. Maybe a grave on the E. I mean, maybe I would probably pronounce Lay and then like, whoops, that's the emoji now. How do I do it? E. There's a lot of letter E's. Oh, Emacs. Oh, it's here. It's just slow. It's very slow. I didn't realize there were so many E's. There's no Latin letter E, apparently. I give up. Or a circumflex plus diuresis, LIE. I just like diacritics, okay? Oh god. That's the one. That's the one right there. If you need a diacritic, let me know. Lamau. Nashiora says, yeah, I did an IPA transcription when I came up with the name, but don't know how people who don't read IPA will benefit more from that. Generally, what I do is like the actual name, and then I have like the pronunciation of it in like layman's terms, which is like la yi, right? You see this on Wikipedia and stuff a lot. And then you have like the actual IPA transcription, which would be like, I can't really do it because I don't have all the characters, but I think I need a, yeah, something like this. For the, is that the la sound? And then the A would probably just be ah. And then isn't like the, that's the symbolic. That's shush. Yeah, I always forget. There's one of them. It looks like this is all I know. Does the average person know IPA? I personally don't. The average person does not. People who are into linguistics like me and Sir Aid definitely know IPA somewhat. What are you trying to transcribe? What? I was just doing la yi. I've all Nashiora says, and me. I've also tried making conlangs a few times. Is it a Yush says, found out I'm an NPC. Oh, that's just such a funny thought. I don't think you're an NPC. But it's just, I can just imagine in Skyrim. Can you imagine like Greta or whatever her name was? She just turns to you and goes, am I an NPC? You have like, what? It's just like her brain explodes. Is it Ayush says, what is IPA? International Phonetic Association or something like that. International Phonetic Alphabet. There you go. Basically, all the sounds you make, we need to write those down. So like when you say ah, it's represented as the letter A in IPA. But if you spell like cop, it's C-O-P. But to pronounce cop, it's actually like K and then an A and then the P sound. So it's more, this is the IPA transcription of cop, I would say. Isidish says, I make too many sounds for someone to record down. That's funny. Actually, the whole point of the IPA is that every sound that is possible to make can be written down. So any sound you make with your mouth can be written down in this way. Hence all the crazy diacritics and a lot of crazy stuff that can happen. But cop is simple, but as soon as you get into things like keep, well then that would be like this. Because the I letter in IPA actually is the E vowel. So this would be k, E, p, keep. There's the extended IPA for sounds that don't really occur in natural languages. Yeah, with all the like clicks and stuff, right? I mean, there's a lot of clicks in IPA, but there's more clicks in the ex-IPA. Little whooshes. IPA destroys you by having 10 songs that sound the same to you but have different writings descriptions. Basically. So Laye is close enough to how I say it. That thing is what he typed, by the way. Laye. I like it. So I would have something like this. right? If it's la yay like that, and then like the actual lay. And if you want like la yay or lay, however you want to typeset it. So is this like the if I'm remembering correctly, is a centralized ah. Yeah, it's so that should be like la yay. If I'm correct. This took a turn. Started talking about linguistics. Pronunciation is difficult. It may just literally be la yay, lol. You should also add the stress. Yeah, you should. Trying to figure out where in my mouth it is. It's true, like, is this sound coming from the forward, the front, the back of my mouth? Okay, well, nobody has asked any questions about assembly. Nobody has asked me to write anything in assembly, so... Like, is it la yay or la yay? I think it's la yay, not la yay. Laya? Is it Laya? Are you saying Laya? It's not Laya, it's Laya? I think I'm getting it now. You know how... Okay, Nashiora, you're local, right? You're local from the Discord. I can get in a voice channel and demonstrate, Lamau. It's okay. I kind of like... Nashiora says, yep. Nice, so you are local. Is it a use? Oi, bruv, it's Laya, innit? So, Nashiora, just include hello, local here. Vsauce, Michael here. Nashiora says, so I got the name by listening to an Australian say layer. That helped me the most. I can picture that in my head and go, oh, Laya. Right? I'm like, Laya. It's not la yay. It's not la yay. It's Laya. If it's what Lens is saying, then it's Laya. Yeah, with the law, okay. This is what IPA is for, because I can't say this out loud. It's Laya. Instead of like la yay. La yay would be that, right? Laya, I think it would be like the diacritic here, which is like the small AI. I know that's not right. Less schwa, more e. Laya. Lai. That's hard. That's hard to pronounce. You've created something hard to pronounce. I will tell you that much. Okay, how about that? How about that? Nashio says, yeah, I know it's hard, Lamo. Is it a use says, call it layer and call it a day. It's layer. We got 22 people in here. It's amazing. Thank you all so much for tuning in. Be sure to check out the Discord in the links down below. If you join, I'll even say hi to you on stream. You'll be on the stream right now. Ooh. And oh man, there's a lot going on. Awesome. There's people doing debugging in the Discord. That's beautiful stuff. I'll have to look at this. Anyway, join the Discord. You get announcements every time I go live, and you get access to this amazing community. And thanks to Local, you now have animated GIFs, animated emotes that you can use. Look at that, if you pay. Thanks, Local. Saraid says, you mean like Leia? This is the transcription, by the way. Also, this is in square brackets, so it's different. What is that? What have you given to me? Vertical line. What have you done? I've never seen this character in my life. This is beautiful stuff. Zarias asks the age-old question, is there a reason you use Windows instead of Linux? There is a reason. Mostly it just has to do with like data, and I don't want to corrupt a bunch of NTFS data. And I don't want to have to like make all my current drives read-only and then have to buy new drives so that I can actually download stuff and install it and have an OS. It's basically, it's both a financial thing and a convenience thing. I don't want to buy 4 10 terabyte hard drives to store a bunch of data. And during all that, having to convert the data into a new file system format. And then it's a mess. Alrighty. Nashiro says, so Laya is goo enough for me. I like goo. Aren't you stuck in Windows forever then, lol? Yeah. I mean, with this computer, yeah. That's kind of how that works. If I have, you know what I mean, like a week where I and $800 to buy hard drives and just transfer data and make sure nothing gets corrupted, and then, you know, it's a mess. And I don't think there's anything wrong with Windows. I think every system has problems with it. Every system has quirks and weird things. Like, have you tried to use real path on Linux? It sucks. Full path on Windows is just amazing, and it works. Nashiora, where to find donate link to send Len some hard drives in time? Actually, it's in the Twitch About section down below. Go check it out. It actually is, though, if you want to do that. That Phase 1 theater mode. Zarias says, yeah, that's why I said I can't like Windows after experiencing i3 on Linux. I think I would definitely benefit from a different window manager. But I also don't like that how many window managers there are for Linux. I think, like, they really gotta consolidate it, because do you know how many bugs I've run into that's like, oh, that's a GTK bug. It'll be fixed in 20 years. It's like, oh, cool, guess I'm screwed then. And you get that a lot by just using GTK and going, oh, I'm trying to make a checkbox and it doesn't work. Oh, it's because I'm passing it this specific flag because I need this specific functionality, and there's a bug and it'll never work for the next 20 years, even though it's supposed to. Terrific Table, just use DWM and fix the errors yourself. Lamau. It's an option. That's definitely an option. This would be cool. Ta-ta-ta. Okay. Coolness. Don't worry about that. Mousex says, I'm on Windows because I have like 30% more FPS in games. It's definitely true. That's definitely true. MouseSX says, it's getting a lot easier and painless to be a GNOME or Plasma normie on Linux, but there are still pain points for sure. Nashiora, much of my entirely too large Steam library has not worked on Linux machines, even with compatibility layers, and I'm still primarily deving Windows for work and pleasure, so those are the biggest reasons. Nashiora, basically until the games I play run natively on Linux and good graphics drivers are easier to come by, I'm here. Well, I'll see you'll be here till the end of days with me, I see. Because there's never going to be good open source graphics drivers, just because of how those companies operate. Anyone notice anything crazy about what's on screen right now? In case you don't know, this is a text editor, which is a text editor I've created. And this is a C file. MouseSX says, because they don't want to make anti-cheat work on Linux. Don't play Riot games. Oh, Lamau. Nashiora says, I plan to support Linux for my projects, but the primary target is Windows forever. Uh-oh. Nashiora says, hell yeah, tree sitter. Zario says, Nvidia stare. Isidiyush, whoa. It's pretty nice, ain't it? It's not perfect. The queries I'm making aren't perfect. As you can see, like, it's the parentheses are highlighted as a function call, but you know what I mean? Or as a definition, the function name. It's not really a big deal, though. And yeah. Another thing that I added recently, which you may want to take note of, is that if we make this fairly large, right? And then we make this very small. Before, we did have scrolling capabilities, which I can scroll right and left, and also I can scroll down and up, as you can see. But I now made it so that the cursor interacts with the scrolling system, so that as you navigate the file, it jumps around to wherever you are. So I'm going to go to the end of the line, and then the beginning, or I can go forward slowly, or backwards slowly, or downwards, and upwards. And this isn't really the real use case for this. As you can see, this is a file with not very much in it at all, right? But it does come into effect when the files are much larger, and you can just easily move about in them. Which it did take some time, I will admit, to get this right. And you'll notice that the theme I'm using may look suspiciously similar to something else you may have seen in the past. You know what I mean? Isidiyush says Emacs. I mean, this is my own little Emacs with tree sitter integration. MouseSX says, I don't see it. They blend in. Interesting. Okay, but yeah, this is my text editor. Isidiyush says, I'm blind in my two eyes. I saw nothing. Lamau. Another thing I did, which we may want to check out, is I've got to implement scrolling of the pop-up buffer. I know. The programming stream of 2022. Basically, the fun compiler examples. I know, it's not ideal. What you'll also notice is that the compiler, the language the compiler compiles, guess what? We also have syntax highlighting for that. So now you can, do whatever you need to do and edit these files as one would, By the way, this is in debug mode, which is why it's a little jittery. And all these boxes are just the carriage return character, which you can actually change to be any byte that you would prefer. So if you want to have hashes be the carriage return, you can make it that. Or you can make it nothing, aka a box. How about that? But yeah, using tree sitter, we can effectively highlight pretty much any language that there's a tree sitter grammar for, which means I could also at this point highlight anything I have. In this file, which is slash that thing basically. Okay, things are a little broken. Let me fix them. There we go. It's going well. There we go. Jesus. So all of these languages I have tree sitter binaries for, which means that all of these languages I can effectively syntax highlight for my text editor. How about that? All I have to do is write the queries themselves. So if I wanted to open Lisp / what would it be? For example, unhighlight. Then you can see that we basically set a bunch of foreground and background colors. We set the language. And then we make a bunch of queries, which is, these are tree sitter queries, which is, for tree sitter, which you can pass directly to them, and then it'll highlight in this color. So you can see a declaration with a name of an identifier will be captured, and then that capture will be colored with a function name. Nashiora says, LITE and LensorOS when? It actually wouldn't be too difficult. Sorry, it says, do we know how to pronounce it now? All right, I'm back. What did I miss? Lamau. Is it a use 5 years from now and Lens would have rebuilt Windows? I mean, hopefully. Nashiora, streaming natively from LensorOS when? That's going to be a while. I mean, using FFmpeg, FFmpeg and stuff, it shouldn't be too bad once we get some basic ports going. Saraid says, by the way, about the tree sitter thing I mentioned, turns out that writing a script that downloads all the repos is the easy part. Well, yeah. The hard part is building all of them because they use different build systems. So I only implemented the downloading part. Lamau. Lamau. Is it huge? Says, a whole editor, Saraid. Welcome back. It's true. I was just showing off my text editor, how it now has built-in scrolling, so you can look at really long lines and not be off the screen. You can also go up and down without having some major issues of confusion. And yes, it's a little laggy. We're still working on the optimization of everything. But yeah, we did it. This is it works really well, and we have syntax highlighting, not for this, but for our other stuff. It's very cool. Very, very cool. It's faster than Visual Studio, so that's a start. It's true. Much faster than Visual Studio. And then once you set up the tree sitter, by the way, once you set up all these queries, they're actually just created. That's a little invisible eye. I wonder why that is. You can just change the one tree sitter language variable and it'll switch between the already initialized things. There we go. Very cool. Just wanted to show that off. I figured it's something cool enough that it's worth it to show. Alrighty. Well, I've got nothing left unless you guys have any remarks or questions or anything you would like for me to do before I go, I've got nothing left, so I'm going to say goodbye and we're going to start winding down here. Goodbye. No, goodbye. Nashiora says, I'd use Lenser Mobile. Isidiush says, Lenser Android when, so I can flash it on my Android. I mean, Android phones are hard because they're ARM 64. And ARM 64 is a whole thing. Shadowprof is Fun Compiler, a good place to start learning about how compilers work. Yes, it's a great place. But I wouldn't say it's a good compiler to learn how compilers work. Does that make sense? It is not the implementation of a compiler and this is how you should make compilers. But as somewhere where you can go and ask the people who make it, how does this part work? Why is this the way that it is? How does this work? That makes it a very good place to start learning. Because with GCC is a much better compiler. 100% forever. It forever will be. We'll never catch up. But Fun Compiler has the ability where you can just talk to the devs and say, why is this way? Or you can look at the internal source code, and if you don't understand a portion of it, go, what does this code do? And you can ask in the Discord. Isidiush, who compiled the first compiler? A computer, a person. Saraid says, I don't know what's going on in the GCC codebase. And the LLVM codebase is fairly sensible if large. I mean, that's just your perspective. I'm sure you can imagine how someone like me, who's familiar with the GCC codebase, would be very lost in the LLVM codebase. And I'd say the GCC codebase is also sensible. Each of them have their setbacks, but I'd say choosing one over the other because of the codebase would be kind of a mistake. They're both C++ C compilers. Not that you shouldn't use LLVM. It's also sensible. Just GCC is also sensible. So, Shadowprof, if you want to learn the basics of how compilers work and the underlying functionality, then yes, I would say Fun Compiler is great. Because you can give it a little example file and have it print you the whole AST of the program. And then you can go into the code that prints the AST and go, okay, that's the data structure it's looping over and that's what it's accessing. And then you could go to the parser and see how's it created. And it won't take 10 years. Whereas with GCC or LLVM, there's a lot of complex stuff that's going on that is just rough. Isidiush says, it's 4 a.m. here and the stream was amazing. Thank you so much. I appreciate that. I had a great old time today as well. Zarias says, choosing compilers as a career can also be a mistake. Zarias is 100% correct. Shadowprof, is it cool with you if I try to follow through the VODs and re-implement it in Rust? If you're talking about the compiler specifically, then the compiler is licensed under the MIT license, which means that you are allowed to do pretty much whatever you would like to do with it. Moving Fast 69, thank you so much for the follow. So yeah, Shadowprof, do whatever you want with it. You could take it and sell it for $300 to each person you meet. I don't care. It's totally allowed. And you can do whatever you'd like. Honestly, if you re-implement it in Rust, I would say, number one, it's changing a lot right now. So be ready to, you know what I mean? You're going to have to keep up with development or choose a specific subset of the language that you want to re-implement in Rust, if that makes sense. I won't be accepting a PR that replaces the codebase, the C codebase with a Rust codebase. But if you make a fork or not even a fork, if you just make your own program that's based on this one, that's really cool. I'd say that's almost the goal of the compiler, is to get people making their own things based on things they've learned and in the compiler. But just know that we rely a lot on like unsafe functionality, and considering that we wrote it in pure C with no dependencies really, then that means that there's a lot of things in there that are going to be very different in Rust. So it says this implementation is still changing a lot too. Yeah. That would also, yeah, that's my warning, is that let's say you choose to do it this week. Next week it's going to be broken. Isidore says, what's a good place to begin learning compilers, Lens? Any recommendations? I don't think I've done this before, but I will shout out this one thing. Let me check. I gotta make sure. Soroid says, if we rewrite it in itself, then that's going to be the canonical implementation, I'd say, haha. Well, currently it is the canonical implementation. The C implementation is, and that probably forever will be. I don't think we ever will rewrite it in itself. We can, but I think the point, I think it'd be better to keep a C codebase. It's not hard and fast. That's not set in stone, but that is where my mind is. Zarias says writing a linked list in Rust, Kappa. So one thing I have done a lot of, personally, is on YouTube. If you look up like compiler SSA or compiler AI, this guy comes up. He has a whole compiler design series, which is super long and has a ton of things. And this does get you started on like the lowest levels of compiler design and optimization and things if you want to do that. See, it's 190 videos. And he also has operating systems and stuff like that. This guy was pretty good. I will say these videos are a lot like school in that some guy talks for about 30 minutes. You're really bored the whole time. And a lot of it is confusing as to how any of it will ever apply. But as you start to work and learn, more and more of it will become understandable. Less of it will be like just nonsense that goes over your head, and it will slowly, be indoctrinated. And what helped me learn about compilers, truthfully, like at the very, very beginning, was Porth. If you don't know Tsoding, I'm sorry. But if you don't know Tsoding, he's amazing. You should definitely go watch him. He's another streamer that streams coding on Twitch and uploads to YouTube as well. And he made this language called Porth, which he made in Python. Now, Python is readable enough where you can look at it and just go, okay, that's what it's doing, you know what I mean? So then I would take this Corth, and what I did is I implemented Corth, which is like Porth, but written in C++, right? So I watched this whole series, and for a lot of it, I tried to build the same things he's building in Python in C++. And then from there, I had a basic working compiler. Now that compiler is horrible. The compiler he writes, I will admit, it's not ideal. It's a lot like the compiler I wrote right away, which you'll notice. And one thing that really isn't ideal is the way that assembly is generated, right? And the way assembly is generated requires all these switch cases, and then these different, he just actually outputs like blocks of assembly based on the operator. This is a mess. This is a mess. This is a bad way to do things, but it works if you only have one type and it's an integer. But yeah, this is a great starting point because you can literally see from the very beginning, here's a program you can write that turns into a compiler. Nashiora says, when he started self-hosting Porth, I think the compiler ended up a lot better, which was neat to watch real time. 100%. I think when he switched to Porth and made it self-hosted, it really did clean up a lot. The Python was really a source for a lot of the issues. It's still a mess, but still neat. I would agree very much, Nashiora. Is it Ayush says, my gallery is 30 screenshots of Len's stream now. Lamau. Okay. it looks like that got resolved. That's good. We have some links here for some helps for some help on writing assembly. Some helps, you know. Be sure to check out the Discord. We have a ton of fun here, and we do linguistics. We do anything. Some person posted a puzzle here the other day. I recommend still doing that. I tried half of it. I'm halfway through, but it's rough. It's a rough puzzle, I will admit. Or I'm just stupid. If you think you can solve it, go solve it. That'd be fun. It's in the threads in main. Anyways, if you join, you'll get announcements every time I go live. You can ask to join the notifs group, and you'll get pinged every time I go live. Hey, how's it going, AJ? Thanks for joining. Nashiroi says, I like the optimization part of this series. It's a good introduction to the kinds of simple things you can do to completely transform the code. Oh, and that's in response to something I missed. For learning about compilers, Biscuit's compiler series is pretty interesting, even though he mostly skips writing a Lexer parser and uses Bison instead. But if you want an overview of how a compiler generally works, then that's a starting point, I'd say. Yeah, I'd say those are all good starting points. Saraid says, self-hosting isn't that hard once we have more features because it's written in C. Since C is so low level, it's basically just be syntactical changes, and some things might even get easier to do depending on what features we end up adding to it. It's then harder to maintain, Saraid. If you want to argue that implementing a new feature in a self-hosted compiler is not harder than implementing a new feature in a non-self-hosted compiler, written in C, for example, I would be very questionable. Depends on the feature, Kappa. Well, yeah. It's just that in order to implement a new feature in a self-hosted compiler, you can't, A, use the new feature, and you can't, B, get rid of the old feature that it's replacing if you're upgrading something. So you have to keep like two versions of something. Then you have to start making like T diagrams, and you go, okay, I have compiler A, I'm going to use compiler Z to make compiler B, and then I'm going to use compiler B to take compiler Z and turn it into compiler A, and then I'm going to, and it's like, it's a mess, man. It's a mess. Yeah. It's not that the language itself would make it any harder to write in C. It's just that if we were writing a C compiler, yeah, but once if we already support most things that C supports, then implementing it in C would be about as hard, I'd say. I don't think that's true, because in C, if you want to change the syntax for dereferencing, you just change it. You say, oh, that function call where it ensures the token comes there, or creates a pointer, or a dereference, or whatever, you just move that. Whereas in a self-hosted language, you have to move it, and then also, everywhere you dereference something, change the syntax in the whole compiler codebase. So if you want to change the syntax of something, well, here's the thing. The compiler that you compile, that compiles code that has the changed syntax, won't be able to use the new syntax, but it also won't be able to compile code that uses the old syntax. So you have to use the old syntax, but not be able to compile code that uses the old syntax. In order to be able to compile a new syntax, then you have to rewrite the compiler with the new syntax, and then you have to compile that with the halfway compiler, and then you end up with a full compiler that uses the new syntax and also implements the new syntax. Are you going to tell me that that's simpler than moving a function call in C? Sir Aid. What? What? Sir Aid, no. The response was, I mean, yeah, that's how it goes. It's a bit of a headache, but you'd sort of run into this anyway if there are any programs written in it. And also, once we get to that point, the syntax should mostly be figured out. Kek W. Yeah, they aren't changing the C syntax or the C++ syntax even after 50 years. It took them a few months, then they got it. It hasn't changed since. Nashiora says, for as long as you want to add features that the self-hosted compiler would use, you shouldn't self-host. Exactly. Beyond that, you can be diligent in not updating the self-hosted, but as the bootstrapped compiler adds features, then you have to be conscious because compiler errors are now gone. All of that to say, I agree, it's much harder, lol. But yeah, if anything is written in it, then any compiler change has the same problems is a decent point. That's not true. It doesn't have the same problems. If the syntax is changing all the time, then self-hosting it is not the best idea. That's what I'm saying. And our syntax changes twice a week. Like I said, I'm not saying we should never self-host or we should never not write it in C. The thing with C and C++ is that they're 99% backwards compatible. We aren't. We just change the syntax all the time. I agree. Self-hosting is cool, but it's not the goal for this compiler at all. The goal is to write a compiler for fun. So it says C compilers don't really have that problem. And yeah, self-hosting it now would be a horrible idea. I'm not saying now. That's fair. We could self-host it at some point. But then I think it'd be better to keep it as a separate implementation and have the actual canonical implementation be the C one. I do have a goal of self-hosting in the future, but I've made the mistake in the past of self-hosting as early as possible. Yeah, bootstrapping is doable, it's just not fun. I'd have to standardize the core of the language and then never change the bootstrapped compiler ever, so it's daunting. Exactly. And why do you want to do bootstrapping, right? I agree that it's cool. It's like, oh, a compiler that compiles itself, wow. But beyond that, the coolness factor, it's like there's nothing useful about it. Nashiora says literally because it's fun. Exactly. It's because it's cool. Nashiora says, same as fun compiler's namesake. Well, I've had an amazing time talking with you. First time chat from Mr. Elfman. Whoa, x86. How's it going? We are just wrapping up the stream now. If you compile the compiler with itself and then use that compiled compiler to compile itself again, and those two executables are exactly the same, then the compiler is working correctly. Yes. But also, if you compile a program and then you compile a program from the assembly that it compiled and then test that, it's also the same thing, right? I see what you're saying, which is that if a self-hosted compiler can compile itself twice, basically, if there's no errors, then guess what? There's no errors. It all works. But, which is a cool thing. There's also other ways to deal with errors. For example, a C compiler can shove you errors in your face. Anyway, I'm bad at this classically. x86 assembly makes me glad C exists. Yes, Mr. Elfman. Nashiora says, this has been quite the involved 30-minute goodbye, lol. You should see my streams. That's how it goes. I suck at saying goodbye. Anyways, I just enjoy talking to y'all, so it's hard to say bye. Mr. Elfman says, ARM does the opposite, though. You like ARM assembly? I don't think it's better, necessarily. It is easier to use, because of all the registers and the, I think the syntax is more confusing, though. Anyway. Thank you all so much for watching. I really gotta go. I've had a great time. Mr. Elfman says, I think it's the future. ARM is definitely the future. ARM 64. And But Intel is going to keep going, and they're a giant tech conglomerate at this point, so they're not going to stop. Isidore says, "Good night, guys. It's 4:20 a.m. now. Pog, 4:20. That means your time zone is half an hour off of mine. That's weird." Zarias says, "Good night. Good night, Isidore. See ya. Mr. Elfman, see ya soon." Anyways, be sure to check out the links. Join the Discord down below to get announcements anytime I go live and stuff like that. Check out the YouTube for all the VODs in the background, all the VODs of the streams that I have done before. And yeah, be sure to check it out. Be sure to check out the Codeberg and GitHub for all my open source projects. And I'll see you very soon. Bye bye!